Okay, we're going to be dealing with chapter 5 and 14. 5 is angles, chapter 14 is traverses. Probably the biggest unit in this particular course. Okay, so this will be busted up into 2 lectures. We'll have one today and then we'll have one next week, and the 2 lectures I would be able to get through all of it. Okay, everybody knows what an angle is, hopefully, by now. We've gone over part of it. An angle is just a dimensional quantity that has degrees, minutes, and seconds, or a decimal of a degree. Once again, if you have the construction calculator, it goes back and forth for you. You don't have to worry about making the conversion. You go from degrees, minutes, seconds back and forth in a heartbeat. So it's just an angular measurement. Okay, it's either going to be in degrees, minutes, seconds, which is normally written like this, degrees, minutes, seconds, or it's going to be a decimal of a degree. So a decimal of a degree would be something like 35.46 degrees, okay? This would be 35 degrees, 40 minutes, 30 seconds. Okay, now we're going to be using these angles as a traverse. Now, a traverse is just a multi-sided figure. Okay? So it's got several sides. The one you're going to be doing out in the field is going to have 8 sides. Okay? We have 2 types of angles. One is an interior angle, which is that. Okay? And then we have a deflection angle. Hopefully you can see that a deflection angle and an interior angle are related to each other. If you know the interior angle, all you have to do is subtract it from 180 degrees. This is the interior angle. If you know that, all you got to do is subtract from 180 degrees and you get the deflection angle. Why do they call it a deflection angle? Because if I had an instrument, I was sitting here and I was looking right down that line and I wanted to get to this next line, I deflect over the number of degrees, minutes, seconds required. So that's why it's called a deflection angle. Okay, a traverse has multiple sides. Okay, depends on what it is. We're going to do one that has 4. Okay, in the field you're going to be doing one that has 8. So it can have many sides. It's many different shapes. Depends on the lengths of the sides and the magnitude of the interior angles. Okay, but there is a little constant that you have to be aware of, and you've got to be able to figure out how many degrees does the traverse have when you add up all the interior angles. Okay, very simple little formula. Okay, it looks like this. And if you want to note it, it's on page 14.5 of your text. The number of interior angles, the sum of the interior angles, is got to add up to a number that is got a little formula that looks like this. So the sum of the interior angles has to equal n minus 2 times 180 degrees. The n is the number of sides of the figure. A triangle would have 3 sides. 3 minus 2 is 1, times 180 is 180 degrees. Makes sense. A rectangle has 4 sides. 4 minus 2 is 2, times 180 is 360. So if I had a 4-sided figure, I would expect all the angles. This one has 1, 2, 3, 4, 5, 6 sides. 6 minus 4, 4 times 180 is 720. So I'd expect there to be, if I added up all these interior angles, for it to close angularly, it has to have 720 degrees. So this is called angular closure. We have to have two types of closure, angular and dimensional. That's the formula for angular closure. The number of interior degrees has to add up to that amount. Okay? So we're going to have to add up degrees, minutes, seconds. Once again, that construction calculator will do that for you. You don't have to go back and forth. If you have a TI, you're going to be in trouble. Okay? You got to change them back, and then you got to change them back again. You lose accuracy in that process, and it turns into be a little bit of a mess. Okay, so we've got angles, interior angles, and of course we have distances. So the distances are going to be between the points. So the length of line 1, 2 would be that. Line 2, 3 would be that. 3, 4, and so on. So what we're going to do, here's the process, and we'll do part of it today, and we'll catch part of it next time. Okay, what do? Number one, I got to make sure the angles add up to n minus 2 times 180. Okay, that means it closes, the interior angles close angularly. That does not mean the figure closes. If the dimensions don't work right, the angular closure could end up with a shape that is not representative of the data. So, number one, I got to make it close angularly. Then I got to figure out the XY components of each leg. So if I draw a figure on the board, and hopefully you can see this, it's a concept you'll need to be able to grasp. Okay? If I have this figure, I'm going to draw it on, I'm just going to do about a 5-sided figure. Okay, there's a figure. Now, I'm going to take what in the past you have related to as a XY component. We're going to change the name of that down the road, but for right now, I'm just going to use XY components. So if I went and I walked from A to B, and I use the sidewalks, I would go there. I would go Y up, X over. B to C. I would do that. C to D. That. D to E. I would do that, and E to A, I would do that. This would be Y1, X1, Y2, X2, X3, Y3, Y4, X4, X5, Y5. Okay, this is the concept you need to handle. If I start at point A and walked on the sidewalks, the red dotted lines, and came back and ended up exactly at point A, what do you know about the sum of this? The amount I go to the right and the amount that I go to the left, if I end up at the same point, hopefully you can see, has to be 0. And up and down. the sums of all the y's. I go positive y, negative y, negative y, positive y. I have to add up to 0. Okay? So, when we get done taking care of the angles, we have to bust each of the legs up into xy components. Okay, to do this, of course, we need an angle and a distance. I know the length of AB. If I know the direction of AB, then I can use sine and cosine to find the x and y components of AB. Okay, to do that, I'm going to need a direction. Okay, we've talked about north before. East, west, south. This angle right here is going to tell me the direction of line AB. Okay, to do that, I have 2 ways that I'm going to introduce to you to define the direction of AB. One is called a bearing, and one is called an azimuth. Okay, a bearing, and I'm going to make up this angle. Okay, that angle right there I'm going to put as 42 degrees, 15 minutes, and 30 seconds. So, if I'm dealing with a bearing, if you've been in Boy Scouts or Girl Scouts and done some hiking and stuff, this probably is going to be a rehash. There's our compass. It's going to have the 4 quadrants, 90 degrees each, north, south, east, and west. The line I just drew is right here. Is right there. So I can define it as a bearing or an azimuth. Okay, let's do the bearing first. Okay, to define a bearing, the bearing is always defined with a beginning letter and an ending letter. So, if I start out with N or S, and I end in E or W. Okay, so I'm going to start at this line or this line. This would be the northerly line. This would be the southerly line. And what will tell me which one I'm going to start at is which side of the east-west line the angle lies. This one lies on the north side of that line. This, if I had a vector down here, that would line up on the south side of the east-west line. So that's the letter you put first. For me, this one, I would use this, north. Starting at the north. The last letter is the direction you head when you, like a clock, from that line to get to your angle. So I'm on this line, and in my case, I gotta go this way to get to my line. That's going towards the east. So I would call that a north so many degrees east bearing. Over here, I would be going south, and I would be heading towards the west line. So this line here would be southwest. And then all we do is insert the angle in between. So north, 42 degrees, 15 minutes, 30 seconds east. And let's say this guy was this. 30 degrees, 20 minutes, 10 seconds. So if I was using this line, I would start south side, I would head towards the west, and I would go 30 degrees, 20 minutes, 10 seconds west. So that's how you deal with bearings. You either start with a north-south, you head east or west. The bearing angle will never exceed 90 degrees. Okay? If it's 90 degrees, if my vector was right here, that would be a true east vector. So the biggest this number can ever be, is 89 degrees, 59 minutes, 59 seconds. If it hits 90 degrees, it's a true east or true west. Okay? So there's a bearing. Now, an azimuth is a brother to a bearing. Okay, so we've got a bearing here already. This one right here is north, 42, 15, 30 east. Okay, now what is the definition of an azimuth? Our azimuths are defined as a northerly azimuth, and the azimuth is defined by the angle clockwise, measured clockwise from north. So the azimuth of this line would be right here. The azimuth of this line would be right here. So that's azimuth. So to find the azimuth, okay.